Because you can see things done over and over and over and over, but that does not mean you can do it. But if you know the directions and see things done, you're generally able to put those two things together and make it work. All right? So, the first one asks you to calculate the discriminant. Do we know what that word discriminant means?
It's discrimination. Sorry.
All right.
Find the triangle.
Okay.
No, but like the triangle equals what is it? B squared minus 4.
The discriminant is the stuff. Hey, I'm technical. Inside, whoops. No reason not to use the right words. Inside
Of the triangle?
the radical. Okay. In the quadratic formula.
Which is B squared minus 4.
Okay? So remember, it's x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. That's the formula. Do you have to memorize that formula? No. But you do have to know that this part
I think you're doing that too, aren't you?
is the discriminant.
Into the triangle equals.
Where are you going with this triangle?
No, the triangle.
Including the square root.
No, just the stuff inside.
Wait. I can't see.
Okay? Just the stuff inside. The b squared minus 4ac. So all you need to do is put the right stuff in the right place using a parentheses. So all you need to do is simply, it's the b squared minus 4 times a times c. And remember, you don't have to memorize that part. The formula is given to you. You just have to know that the discriminant means that piece of it. Okay? So replace the variables with the correct values. Make sure you put A in place of A and B in place of C, etc. And you don't even have to worry about that too much because right above the quadratic formula, they give you the general form of a quadratic, which tells you A is in front of the x squared, B is in front of the x, and C is the constant at the end.
Do you have a copy of the formula sheet?
I do, and I was thinking formula page, so you don't have to remember the discriminant formula, but they don't say discriminant. They give you that triangle with one dark side on it, the delta. That is the symbol for the discriminant. Okay? So it's there. Okay? Or change. There you go. All right, so there it is on there. Okay? All right. So do you see that that's all you have to do is plug the numbers into the right spot and then do the math. Make sure you do your signs, okay? Watch out for those signs. Make sure you put your signs in there. Okay? All right, the second one, solve the logarithmic equation. Remember, that's one of those where you're just given, like what we did, right? Here, what exponent would turn a 4 into a 2? Yeah, it's getting smaller, so that means it's a fractional exponent, right?
Yes.
And it's 1/2, because you're taking the square root of it, right? The square root of 4 is 2, so 1/2 is the exponent. So do you see how if you know the laws of exponents, if you know what exponents do, then it's easy to see what the logarithm would be. Okay? We're making the 4 smaller, so that the only way to be able to do that is to use a fractional exponent. Okay? What if I made the 4 into a fraction? That means I was using a negative exponent. Okay? Excellent. Good. Okay. Let's see. The next one is just a really, really, really ugly version of a simple logarithmic equation, right? So you have, remember that if you have some x to the n equals some number. Do you guys use G? She wants G? Okay. All right, so that just means that it's the logarithm of x, and where does that exponent end up popping into? In front, right? So whatever the exponent is, it just becomes a multiplier. But if you take the logarithm on one side, you have to take the logarithm of the other side. Okay? Yes. And there is your clue to this problem. The whole thing that made this problem doable and not an insane problem is logarithm of 1. Because if you have logarithm with no base, what do you assume that base to be? There's a base 10 down there, right? And what's the only exponent you can put on a 10 to turn it into a 1? 0. So what you end up with is having a 0 on that one side. So when this side turns into a 0 and you divide logarithm of all that junk, that huge thing, right? Because it's a gigantic, that's a logarithm of 2/3, okay? Because it's just ugly. But we don't have to worry about it because that turned into a 0. And 0 divided by anything is 0. So what you ended up with is simply a quadratic equation already set equal to 0 for you. So look at this. Any time you can take the logarithm of one of the sides you build, if you can take the logarithm of it very easily, then do so. Because if you can turn a logarithm into a number, then you're a lot better off. Okay? Especially if that number is 1 or 0. All right? So that was the clue there. It was ugly. All right. Now let's talk about the one y'all really hated. All right? Now, remember, these are equations that are quadratic in form. What that means is something squared something squared. So that means it can be anything, but raised to the what power? Second power, right? So it can be a logarithm, it can be anything. Pardon? Quadratic in form. Sorry, my handwriting is terrible. Quadratic in form. Okay? Something squared plus or minus something, the same thing. That says same thing. Okay? Equals something else.
Or plus minus something else equals 0.
Okay.
I have no idea
Well.
what I'm saying.
Maybe she's making up stuff. Okay? So, just let u equal the same thing.
Equal to something.
Pretty much, yeah. Because it doesn't matter what it is, as long as this and this are the same thing.
Is this the one where you say lit P or lit U?
Okay? Yes, this is 3i, whatever that is. So what is that?
3I.
B-I-I-I. Okay? So, let me show you what I mean. But look at what I've written, guys, because this one was one of those that y'all said y'all had never seen this kind of thing before. It's quadratic in form. So you have something squared plus or minus that same thing, usually with no exponent. Okay? So for example, if I have the log of 4 squared plus or minus, doesn't matter, so let's just do plus the log of 4 equals whatever. This would be an incredibly difficult logarithmic equation to solve. But do you notice that this one is raised to the second power? And this is the same thing raised to the first power, to no power? Then that's when you can use the u substitution. Okay? So here we could let u be logarithm of 4. And if you want to use x instead of u, it's fine. U is just traditionally used to show that you did a substitution. And so that means this would be, her puns are getting worse. That would be u, then it would become u squared plus u equals whatever. Which is a very, 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 very simple quadratic equation. Okay? So, look for a pattern. So if it's got a logarithm squared, then chances are it's a u substitution. Okay? All you have to remember, though, is that when you get the answer,
You cry.
You smile.
you substitute. Because you didn't get logarithm of 4, you got u, right? No, you didn't.
You find the x, so you're solving the x, so you do u.
You've got to plug it back in, so then solve to find out what it would be. So you've got to substitute back in to get it.
U equals log 10x.
Yeah. Okay?
Oh, wow.
All right. Okay, then there's one. The next one is just that P equals ART thing. We've done that. The next one is P equals ART thing again. Done that. Then they give you simplifying some fractions and some rules for exponents. I'm not sure what that's all about, but we're going to go through them. So let's see what it says. Remember to simplify a fraction. These are called rational expressions. Which are big fractions with letters.
Wow.
Now, listen, I'm telling you, it makes you remember this stuff. So big fractions with letters.
Then we might laugh in the middle of an exam.
Well, that's a good thing.
No, it's not.
Because then you distract other people.
And you're going to get kicked out of the exam.
Well, you're not going to go berserko laughing, but you can have a smile. Okay? Pardon? So to simplify them, the first thing is you have to factor. But y'all call it factorize? Factorize? Everything. Right? Numerator and denominator. Then simply eliminate the common factors in numerator to denominator. Okay? You have to be going across the fraction bar to eliminate them. So you need to be able to factor. And I'll put the videos for factoring on your sheet. I didn't do it, but I'll try to get that done. Okay? All right. They'll be there. And they're step by step with examples. Okay? All right. Then the next one was a law of exponent one. We have 2a over 3b squared all raised to the negative 2 power. The glaring thing about that should be the negative exponent. Negative exponent tells you that the numbers that you're raising to the powers are in the wrong spot, right? So anything that's in the top should be where? In the bottom. Anything that's in the bottom should be where? In the top. So that's the first step, the negative exponent. So that would turn it into 3b squared over 2a, all raised to the positive 2 power now. Because once you flip them, once you move them, then the exponent is not negative anymore. And then it's simply a matter of raise, oops, I can't spell, everything inside to the second power. Power is just another word for exponent index. Okay? Raise everything inside to the second power. So you're not just adding exponents here, you're raising everything in there to the second power. Every single piece of it. So that's the same thing as saying 3 squared, b squared squared, 2 squared, a squared. Everything gets an exponent of 2. Right? So that gives you 9b to the 4th over 4a to the 2nd. And there's nothing common to the top and bottom, so that's where you have to stop. Okay? So if you have an exponent on the outside of a parentheses, it means to raise everything there, but you can't do it if that exponent is negative. You have to get rid of the negative exponent first. Get in the habit of getting rid of negative exponents first always. Of course you may.
Oh, don't lose that yet.
It's 2.
Yeah, we're not doing a lot of examples. I didn't do this one right. I put the rules on the wrong side and the example on the wrong side. I'm not following my own darn rules, am I? Okay? The next one was another U substitution. It's something that's quadratic in form, and you can almost always tell that they're quadratic in form because they look ridiculous and impossible to solve. Look at this. It's 2a to the 4/5 power equals 5a to the 2/5 power minus 2.
Is this a new one?
Yeah, this is new. This is C. Okay. This one is indeed quadratic in form. Because, do you see this 4 in the numerator? That's all I care about. Do you see this 2 in the numerator? That's all I care about. Because 4 is a square, isn't it? And 2 is its root. So I have something squared there. Right? So I'm going to do U substitution. Now the process doesn't change. That's a lot of T's. There we go. That's what I'm going to do. All right. So, but look at what I'm going to make U be. I have to take this whole thing and take out everything but a square. Okay? I said 4 is a square, isn't it? What's the square root of, and so what number times itself makes 4? 2, right? So I'm going to turn that into U squared. Well, Okay? Here, and again, I'm only working with the part that is actually part of it. So the 2 is not going to change, right? This is the thing with the exponent. That's the thing I'm going to work on. So a to the 4th, a to the 4 over 5, is the same as saying a to the 2nd times 2/5. Is that too big of a stretch? It's ugly, but you see what I'm trying to do is I'm trying to turn that into something squared. So I'm just dividing out a 2 out of the top. And so that can become my u. Now, a to the 2/5 can become a to the 1 times 2/5. Because I want it to have an exponent of 1. Do you agree? Right? So, in other words, what would give you a way of writing that where you have those? So, what I can do then is let u equal a to the 2/5. Because you see that that's the common piece of them, both? Right? A to the 2/5. So that's our u. Now this one is a convoluted one. So let's look at another example where it's pretty much the same kind of idea. 4x to the 4/3 plus 2x to the 2/3 equals, who cares? All right? Do you see the two numerators in the exponents? One's a 4 and one's a 2, right? So I can write that as x to the 2 times 2/3 and x to the 1 times 2/3. And now I have a square and I have an x. Okay? That one might take a little work, a little looking at and practicing, but it's worth knowing. Here's a process that you can use, all right? I believe in it 100%. For those of you especially who think you can't do math or math is not your thing, whatever, here's the way I approach a problem. I am not a mathematician.
You're a math teacher.
I have a master's degree in math. And it all came from hard work, because every once in a while I do 2 times 6 and get something that's not 12. I have to think about every part of the process. Whereas there are lots of math teachers, you can walk up to them, not in my class, and you walk up to me and say, Mr. Self, I have a question about this problem. It's like, well, you leave it with me because I'm going to have to think about it before I can do it for you. Whereas other people can look at it and go, okay, all you need to do is this, this, and this, right? I'm not one of those people, but I can do it. And one of the ways that I've been able to do it all this time is by working harder, or working smarter, actually, not even harder. So let's say that I have x squared plus 3x equals 9. Okay? What I would do is, first of all, I would say, I know it's an equation. What kind? I know it's quadratic. Okay? So, yeah, that's true. And then I could use the quadratic formula to solve it. Then go back and do that. So every step of the way, I'm writing the process. Now, I don't have to do that now. For quadratic, I certainly wouldn't do that. I know the process. It's in my head now enough to know how to do it. But that doesn't mean it's always been that way, and it doesn't mean that's the way for every problem. If you looked at me grading some of these, not the algebra one, I'm pretty good at it. But if you looked at me grading some of the ones that I hadn't taught in a while, the probability and the calculus ones,